Hello students, welcome to EPG Pathshala. I am Dr. Prasanna Kumar Patra from Utkal University, Bhubaneswar. Today we will discuss about the module Methods of Studying Human Growth from the paper Human Growth, Development and Nutrition. Let us see what we are going to learn from this module. This module will focus on different methods employed in studying growth pattern among population groups. It will elaborate on the advantages and disadvantages of studying growth of children in all age groups, following cross-sectional, longitudinal, semi-longitudinal, linked longitudinal and mixed longitudinal design. Child's net growth at a given point of time is a resultant of interaction between genetic and environmental factors. A child's growth rate reflects his state of health and nutrition better than any other single index. The average value of children's heights and weights reflect accurately the state of a nation's public health. The relevance of human oxyology as predictor of health status of individual as well as population as a whole has evolved considerably over the years. It involves concepts which are closely related to the processes governing today's rapidly changing biosocial environment. It is well known that child's net growth at a given point of time is a resultant of the interaction between genetic and environmental factor. The childhood environment and growth in particular offered as possible predictors of health outcomes and longevity have scarcely been studied, perhaps for want of either necessary infrastructure or use of proper and precise methodology. For proper understanding of the concept like maximal growth may not be equal to optimal growth. Also, to explore if adult stature is a proxy measure for growth during childhood, relationship of disease and other growth affecting factors should be more rapidly demonstrated by directly relating growth parameters to later health outcomes. Hence, to understand aforesaid issues, it becomes imperative on the part of health professionals, oxyologists, anthropologists, and nutritionists to use precise methods of studying human growth to arrive at meaningful conclusions. Rather than merely quantifying the extent of change that occurs in different body parts of a growing child. During growth examination surveys, children investigators are more concerned with mean values and accompanying different measures of variability statistics pertaining to any of the body parameters measured amongst group of children rather than with the nature of growth pattern exhibited by them. Therefore, to obtain adequate set of age and sex-specific data to be used for comparative evolution, researchers most commonly adopt cross-sectional or longitudinal approach to carry out research in the field of human growth. In between a mixed longitudinal or semi-longitudinal or linked longitudinal method that represents short-term limited application of the longitudinal technique or an extension of cross-sectional approach is often employed. It talks about different methods of studying human growth. Those methods are cross-sectional method, longitudinal method, mixed longitudinal method, linked longitudinal method, and semi-longitudinal method. In this slide, you can see a group of children belonging to the same age group. They represent cross-sectional studies and how they represent, we can see in the next slide. A cross-sectional method of studying human growth involves measuring children only once during the entire tenure of the study. For example, in this method, a group of children being measured at 6 years of age would be altogether different from those who might have measured a year ago, or whom one might be proposing to measure later at the age of 7 years. Hence, in this method, there is no element of periodic assessment. Cross-sectional surveys provide information about distance growth attainments of different body parts of the children and reveal enough about the basic nature of the distance growth curve of any anthropometric parameter. In making cross-sectional standards, the numbers of children measured in each age group should be approximately proportional to the rate of which growth is taking place. Thus, about 3 times as many children should be measured in the first year after birth as at age 8 to 9 years. For example, put another way, the first year should be broken up into 3 periods, that is 0 to 0.32 years, 0.33 to 0.66 years, and 0.67 to 0.99 years, in age group of which same number of children should be measured as in the middle childhood year. The second year should be broken into 2 periods, that is 1 to 1.49 years and 1.50 to 1.99 year. Major standardizing studies sample about 1000 boys and 1000 girls in each age group, but half this number produces useful centiles. Samples of less than about 300 in each age group are unsuitable as cross-sectional standardizing series. Let's discuss about the advantages of cross-sectional method. This method of studying growth is cost-effective and less time-consuming, more easily controlled. It involves much larger number of subjects and provides good deal of information about distance attainment or gross size of children. For example, 10 kg of body weight and 76 centimeter of spine length at 1 year of age. This method is a rapid way of assessing the magnitude of growth or nutritional deficits and other health problems prevailing amongst children, representing different communities at given point of time. In this method, large number of subjects could be measured in a brief duration. Thus, data generated through cross-sectional surveys are often considered as better representative of a population and may be used to establish cross-sectional growth standards. And the disadvantages are, owing to their basic inherent nature, cross-sectional studies have one chief drawback. They can never provide information about the differences in rate of growth, that is, growth velocity of different body parameter, as they remain devoid of periodic follow-ups of children. Actually, it is these differences which provide insight into the dynamics of growth of children known to be controlled by genetic, variety of environmental, nutritional, psychological, socio-cultural, and economic factors. Another limitation of cross-sectional data is it does not precisely reveal about timing of occurrence of some particular phases of growth of children, like the onset of juvenile growth spurt, adolescent and attainment of peak height velocity, etc. in clear terms, as cross-sectional studies do not involve repeat examination of children So, growth velocity related information obtained from such data misleads to arrive at faulty decisions. Therefore, it is a question computation of growth velocity of any body parameter should never be made from cross-sectionally gathered sets of data. The cross-sectional surveys, being one edge point specific in nature, reflects conditions only during one season of one particular year, thus provide limited opportunities to have complete insight into the process which affect growth or nutritional status of population of people and their lifestyle. Thus, to obtain such standards, we need a longitudinal study. This is a very interesting slide which shows different stages of human life, starting from infancy up to old age. Longitudinal method. In a longitudinal method of studying human growth, each child enrolled in the study is periodically measured for one or more body parameters at fixed time intervals throughout the study plan. For example, all children measured at age 6 years will remain as the same as those who were earlier examined at age 5 years. The constancy of sample size and strict adherence to stipulated periodicity at which children are to be followed up remain the prime requisites of this study. A growth study may be longitudinal for any number of years. It may extend postnatally from birth to even 20 plus years. However, in actual practice, because of variety of reasons, it may not be possible to measure same group of children over a prolonged duration of time. To obtain the simplest type of velocity standards, individuals have only to be measured twice. This is what was done in the large-scale London standardizing study of 1996-97 and the Cuban national study of 1972 to 74. More intensive longitudinal studies follow the children over longer periods. The investigator then has to fit a growth curve to the serial measurements of each individual. For many purposes, graphical fits are sufficient, but mathematical curves may also be employed. The major drawback of a comprehensive longitudinal study is the time it takes to complete and the relatively small number of subjects that can be followed. To overcome these problems, Eveleth and Tanner in 1976 suggested a good design of linked longitudinal studies that we will discuss in next slides. In this slide, the figure given shows the distance curve of growth of a son and some students, those who were the first to be studied longitudinally. The Count du Montbéliard of France measured the stature of his son every 6 months from the boy's birth in 1759 to his 18th birthday. These data are usually considered to constitute the first longitudinal study of human growth. This was thus the first example of a distance curve of growth. Another 18th century longitudinal study of growth is that of the students of the Karlsruhe conducted between the years 1772 and 1794. The growth data showed that the sons of the nobility were, on average, taller than the sons of bourgeois during the growing years, but that both groups achieved an approximately equal height at 21 years of age. Thus, the sons of the nobility experienced and advancement of the rate of growth. In 1835, Lambert Adolphe Quetelet published the first statistically complete study of the growth in height and weight of children. Quetelet was the first researcher to make use of the concept of the normal curve, which is in today's it is commonly called the normal distribution or bell-shaped curve, to describe the distribution of his growth measurements, and he also emphasized the importance of measuring samples of children rather than individuals to assess normal variation of growth. Statistical approach of Quetelet was followed in Europe by Luigi Pigliani. He began his studies on the size and fitness of Italian military personnel. He later applied his methods to children and demonstrated that the growth status of orphaned and abandoned boys ages 10 to 12 years improved after they were given care at a state-run agricultural colony. Pigliani also noted that children from the higher social classes were taller and heavier than poverty-stricken children. Finally, he was taking longitudinal measurements of the same children. From these, Pigliani noted that menarche almost always followed the peak of the rapid increase in growth that takes place during puberty. Various advantages of longitudinal study. They are: 1. It economizes on subjects. 2. It can provide information about individual change. 3. Longitudinal studies, besides providing information about distance, that is gross size, growth attainments, also provide growth velocity related data which offer true insight about the growth rates, velocity of different body parameters with which these change periodically over a period of time. Such changes in the different body parts of a growing child may be incremental or decremental in nature. As the growth velocity denotes innate capacity of a child to grow and develop, so these studies help to understand the influence of various environmental, nutritional, seasonal variations, disease and climate related factors on growth dynamics of children. Then, most illnesses in childhood are short-termed. Longitudinal studies provide opportunity to have information about the duration of any disease or nutritional deficiency with which any child might have remained afflicted with for a longer period. Similarly, effect of any intervention, that is medical or nutritional, may also be assessed precisely through these studies, as children included in such surveys are often monitored periodically. We discuss various disadvantages that the longitudinal growth studies have. Longitudinal growth studies are very expensive and difficult to organize. Lot of time and effort are consumed to carry out, analyze and interpret voluminous data which are often generated over the years. These studies require a lot of motivation, commitment as well as patience on the part of both subjects as well as researchers to be present on the stipulated date and time of examination during the entire duration of the study, which in fact for obvious reasons is not possible for a very long duration. Longitudinal studies involve examination of limited number of children. It is not always possible to maintain consistency of sample size throughout the entire span of the study. These studies exhibit substantial sample attrition rate. Many subjects have to leave the study as they move to new places, mainly because of social as well as occupational reasons. Additionally, longitudinal study is computationally very intensive. There is also a lack of difficulty of using software. Hawthorne effect. This is unique but not commonly known phenomena in the context of human growth. The principal drawbacks of longitudinal studies are the time these take to complete and the small number of subjects that can usually be followed up. One of the ways to maintain adequate sample size in such studies is to generate a high level of involvement amongst children participating in the study. The phenomenon of greater involvement of parents in a longitudinal series yields to Hawthorne effect, which results from subjects knowing that they are a part of study. According to Johnson, continuous and persistent healthcare advice to the parents whose children are a part of longitudinal study may become aware of relationship between growth and needs for proper environment. As a result, they may change their children's diet included in the longitudinal study. Linked longitudinal studies. Linked longitudinal method studies covering the age of 0 to 6, 5 to 11, 10 to 15, 14 to 20 years. Through this design, within a period of about 6 years, whole age range of growing phase of human life could be spanned by considerably maintaining longitudinal element of the study. However, to obtain smooth joins of the data collected during short intervals and efficient sampling of the population has been advocated by these authors. So, a careful initial sampling design requires to be followed and subsequently adhered to so as to obtain suitable sets of distance and velocity growth related data on children growing under a variety of urban, rural and other different environmental and socio-economic circumstances. For an intensive investigation of the relation between continuously unfolding events in individuals and very often for clinical investigation of growth disorders, long-term longitudinal studies, even from birth to maturity, are necessary. For some outcomes, types of problem, follow-up studies suffice, wherein a cohort is studied at relatively few ages. The British National Child Development Survey is an example, wherein a national sample of all children born in 1 week of March 1958 was studied again at ages 7, 11 and 15. Depending upon the objective which one wants to accomplish, results from short-term longitudinal data can also be obtained, where only some phases of life, that is infancy, preschool years, pre-adolescence and adolescence, could be studied even at larger age intervals, that is 6 months or yearly, but with reasonable accuracy. Now, we will discuss mixed longitudinal method to study human growth and development. A series study in which a group of children is followed such that some children leave the study and others, if desired, join it as new entrants at some age point is termed as mixed longitudinal study. It is not always possible to maintain constancy of sample size, particularly when a longitudinal study is to be carried out for a number of years. Usually, in populations which show more of mobility, children often accompany their parents and leave the villages or towns or cities, etc. Many a times, some children, because of unwillingness, stop participating, and others, particularly during adolescence, feel reluctant to get examined for sexual maturity ratings, etc. And often do not report for examination. In addition to this, many a times, some local, seasonal, socio-economic and health-related reasons come into play and children fail to report for investigations. The reasons may be of permanent or temporary nature, but these affect the sample at different age points. On one end, the variable sample attrition rate experienced by subjects enrolled in a mixed longitudinal study due to variety of aforementioned reasons results in accumulation of data with missing values, but on the other hand, this design provides the opportunity to make up for the sample loss if desired by enrolling new subjects at any requisite age points. Mixed longitudinal studies are relatively cheaper to conduct and are also less time and effort consuming as compared to pure longitudinal studies. These studies, like pure longitudinal studies, provide us with both distance and velocity growth related data with reasonable authenticity. However, estimation of growth velocity of different body parameters from mixed longitudinal data involving missing values is a tedious task, and special statistical methods are required to get maximum information out of such data. To extract out maximum distance and growth velocity related information from mixed longitudinal series, that is one in which children enter and leave the study at a different age, giving variable degree of longitudinally, the use of statistical methods given by Tanner 1951 and Goldstein in 1987 are found to be most efficacious. In the past, it has been noticed that in most of the instances, researchers have treated their longitudinal data are recorded. At the second observation, there is a dropout of 10 cases and we record 90 cases. At the subsequent visits, the number of dropouts increase so that at the end of the study, at 5 years, the numbers of children who have been included in all observations are only 30. So, from this study, we have a pure longitudinal study in only 30. But the relevant data also from the rest 70. In these 70 children, we can, by using appropriate mathematical devices, convert this data into a velocity curve. In another type of mixed longitudinal data, a cohort changes with progress of time. If at the outset we have 40 cases to start with, the cohort might build up to 50 cases at the second occasion, then with further dropouts reduced to 30 at a subsequent occasion. So, data can also be incorporated into a velocity curve. This type of study is a compromise between a cross-sectional and pure longitudinal studies, and we can have some information like longitudinal data besides what is obtained in a cross-sectional study. These studies are less expensive and less time consuming compared to pure longitudinal studies. They help us in getting efficient estimates with minimum variance of average at points on increments, velocities and acceleration of growth for the different anthropometric measurements for comparison and to detect any abnormality of children during their growth period. So students, let us summarize what we have learned so far. By the very nature of their field of study, health professionals, oxyologists, anthropologists are concerned with change that occurs over time. This fact brings to the light the need to choose research design to arrive at meaningful conclusions rather than merely quantifying the extent of change that occurs in different body parts of a growing child. So far, 5 methods have been employed in growth studies. These are longitudinal method, cross-sectional method, linked longitudinal method, mixed longitudinal method, and semi-longitudinal method. Longitudinal studies involve studying the same group of participants over a particular time period. Cross-sectional studies involve studying groups of participants in different age groups at the same point in time. To overcome the disadvantages of longitudinal studies, Eveleth and Tanner suggested a good design of linked longitudinal studies covering the ages of 0 to 6, 5 to 11, 10 to 15, 14 to 20 years. Through this design, within a period of 6 years, whole age range of growing phase of human life could be spanned by considerably maintaining longitudinal element of the study. The mixed longitudinal studies are one in which a group of children is followed such that some children leave the study and others, if desired, join it as new entrant at some age points. Semi-longitudinal study is a compromise between cross-sectional and pure longitudinal studies. Thank you.